Okay, today we're going to talk about finding an inverse of a function. And right here I have a function f of x equals 2x plus 5. So in order to find the inverse of this function, I will simply rewrite it. F of x equals 2x plus 5. And I will write it as y equals 2x plus 5. Because f of x is the same thing as y equals. So then I interchange x and y. So x equals 2y plus 5. And then on this I solve. And I go minus 5 minus 5. X minus 5 equals 2y. Divide by 2 on both sides. And I get f of negative 1x. Now this does not mean that it's to the negative first power. This is just a notation in order to show that they are inverses. So it would be x minus 5 over 2. Now, for inverse functions, this original function was simply a linear function, so this is mentally what it will look like at this point. But from there, what I can do is I can also prove that they are inverses, because the original function and the inverse, the relationship is that the inverse undoes the original function. So by doing this, I will do f of f negative 1x. Now you don't have to use brackets. The simple notation is parentheses, but I use brackets just to make it easier. So then underline from here, because this is being substituted into this other function. So I'm basically putting 2x minus 5 plus 5. This will be the same thing, because what's going to end up is it's going to equal x. Now that means that they are inverses, because they both equal to x when you do this, the f of f negative 1x. And even if I did f negative 1x of f, it would be the same. It would equal x, because I know for a fact they are inverses. And let's do another problem. If I have x squared plus 2x, this is a quadratic. This is, so you tell me, is it going to be a one-to-one function or many-to-one? Now the answer for this is going to be many-to-one. So I can't really find the inverse. It has to be 1-to-1 for me to find the inverse. Except if they give me x is greater than or equal to 0 as a kind of requirement, then it would only cut off half of it, which would make me able to find the inverse. So for a quadratic, I would just f of x equals x squared plus 2x. And then by doing this, I would just be y equals x squared plus 2x. X equals y squared plus 2x. Actually, let me change this to 2. Simply 2. So 2, 2. So it's going to be 2, 2, 2. So what I'm going to do is minus 2 on both sides to solve. X minus 2 equals y squared. So what I'm going to do on both sides is find the square root. So in other words, f negative 1 x is equal to square root of x minus 2. I can also try plugging this in as well. When I do f of f negative 1x, that would also equal it out to x. So I don't really need to do that here. Another one would be more like f of x equals the cubic root of x plus 3. So y equals cubic root x plus 3. Now, I'm gonna cube on both sides just to get rid of that root. So it'd be y to the third equals x plus 3. It's important that you do not make mistakes when transitioning from here to here. And then minus 3 on both sides. I forgot to interchange. Forgive me. This is a simple mistake, so please try not to do what I just did. X equals cubic root y plus 3. So then, do the same thing. Go on both sides. 3 equals y plus 3. So before here, it's important that I interchange the x and y. I simply forgot. And then minus 3, minus 3. That would give me a whole different answer. Minus 3 equals out to f negative 1 x. So with anything, you're just going to set it as a y equals, and then interchange x and y and solve. So in any case, you can solve it by, if it's like a cubic root, you would just cube both sides. If it's a cube, you would cubic root on both sides. It works the same way. And with inverses, their graph should look like symmetrical to the line y equals x. In other words, their graph is going to like just reflect over y equals x. Now that's important because if they give you a graph that looks like that, then that has to be an inverse graph. They must be inverses. But more importantly, quadratics can't have inverses, so if they ever give you a quadratic, it has to be x is greater than or equal to 0, because it has to be a one-to-one to have an inverse. So otherwise, that's it for inverses. So if you have any questions, just ask.